I was surprised and pleased when Michael contacted me and said, "Would I present at your conference today?" So it is indeed an honor. So this is a completely different end of the scale to what we heard from Deepak Gadia. So this is our experiences with solar cooking, really, and this is a summary of the last 2 to 3 years. So I'm the engineer, and Jane is the chef that has helped me achieve some of the, test out some of the technology. So globally, this is a map from Solar Cooking International, just showing you the scope for solar cooking. And you can see most of India is in the optimal region, where the whole of Britain is in the least sunlight area. So already you can see some of the challenges we had. And then if you look within Europe, certainly in Faro, when we attended the conference, it was, although the weather on the particular day wasn't good, it was good conditions for cooking. But here we are in the north of England, York is somewhere here, it's tough to cook consistently. And our aim was to solar cook as much as possible throughout the year. So I won't go through all the sort of different conventional cookers that we've had, parabolic, box cookers, panel cookers, etc. But look at how we overcame the challenges of what we had for cooking throughout the year. So we live in York. It's a lovely, pretty city. That's York Minster. It's got some of the oldest stained glass, biggest stained glass in Europe. Well worth a visit, and got nice river flowing through, and that's Riverside Pub there. But it's also a very wet place. So if you look at the same pub when the river is flooding, that's the River Ouse in flood. So already you can see some of the challenges we have in terms of wet weather. And that's us out and about today for a walk. So because we were going to be indoors all afternoon, and it was raining all morning. Some of the challenges, of course, due to the latitude, is the low sun angle in winter. And this is, again, a graphic from SCI in terms of optimal cooking position, sun cooking position. We've got low outside air temperature, which means that whatever heat that we gain from the sun for cooking can be lost. And often we have days where we might have an hour of sunshine, an hour of cloudy weather, and then a bit more sunshine. So with conventional solar cookers, even with parabolics, it's difficult to cook. For radiated heat, it's possible to use glass or a plastic bag to prevent radiated heat from escaping, and that's conventional with most solar cookers. But the challenge is to stop heat loss by convection and conduction. And if you have low air temperature and windy, rainy weather, then that heat loss is quite high. So the key to cooking at 54 degrees north is good insulation. And here's where we found the vacuum tube solar cooker very useful. So here's the Slick, and I think you might hear more about Slick from the next speakers, Dave Oxford and Stuart McLachlan. And Jane and I have learned a lot from them, and certainly the Slick cooker is quite useful. So, and that's it. It packs away, and here's us making baguettes and cakes in the Slick cooker. And if you don't mind, I'll just play a little video in a second. So that's cakes, tortilla, baguettes, and I'm going to come out of that. Minimize you. Actually, that should play.
Maybe you can restart it, PowerPoint. Okay.
Yeah.
So it's low. Okay.
Okay. Yeah. So this is in January. Outside temperature was near 0. And you can see the long shadows. The vacuum cooker is certainly a solution for cloudy days, for winter, but we still need clear sunshine to use them. So we still need another solution to allow us to cook all year round and cook inside. So these were the challenges we set ourselves, really, to be able to cook in the evenings and to use inside. So for this, we came up with a solution of using a solar panel to allow us to do that, and a battery. So for harnessing the solar energy, a PV panel, a charge controller, battery, and for cooking from the battery, we've got a heating pad, and I'll explain all this in a second, an insulated box, a well-insulated box, some sort of temperature control and timer. So that's what I'm going to talk about, and I'll give you rough costs and things of what we had to do to get us off the ground. The questions we were asked along the way is this efficient? I think Deepak's already mentioned that PV panels are about 20% efficient. But Boniface, could I ask you to mute your microphone, please? Boniface?
I think, can you hear me?
Yeah, please mute your microphone.
Do I mute it?
Please mute it, thank you. The question we get asked, brilliant, thanks very much. The question we get asked is this efficient? And when you're faced with cooking or not cooking, a few percent efficiency does not make a difference, because if we had panels that were 25% efficient or 30% efficient, it doesn't really make much difference if you cannot cook. So if this is a workable solution, efficiency is not a big issue. Is it solar cooking is another question we get asked. So solar cooking purists would say that using a solar panel and a battery isn't pure solar cooking. But living in York, it is our only way of solar cooking year round. So it's better to do some form of solar cooking than none at all. And does it work? Yes, it certainly does. And I'll go through the steps with you. So that's an idea of sunshine per day in the UK. And that's our challenge. So in the winter, we might get 1 to 2 hours, and in the summer, 6 to 7 hours. So for harnessing the solar energy, we just use a 100-watt panel on an outbuilding. And that's typical energy that we could harvest in a day in the UK. So in the summer, we would harness about 300 watt hours. And in the winter, about a third of that, 100 watt hours. And that's what's saved in the battery. So to store the energy, we use just a common leisure battery, so that these are deep cycle batteries that are used in motorhomes and caravans. And this particular size of battery would store around 1,320 watt hours of energy. But with lead-acid batteries, you only really recommended to use half of that. Because the battery would have a very, very short life if you used a lot more. So the usable energy out of that is 660 watt hours. Then in between the solar panel and the battery, those of you who worked with PV panels will know that you need to use a charge controller. This basically manages the charging and the discharge of the battery. Will protect the battery from total discharge, protect the battery from overcharging, and really allows you to get 6, 7, 8 years use out of a lead acid battery. And that's a typical connection, very, very easy technology. PV panel connects to the charge controller, the battery connects to the charge controller, and the load, in this case, the heating pad, connects to the charge controller as well. And voila, you have a system for harnessing. I'm going to talk to you about the cooker itself. So the heating, we looked around for an optimal element that we could use to convert the stored electrical energy into heat. And we came up with this heating pad. They come in different power. This is a 120-watt one. It's really designed for heating the beds on 3D printers, but they're ideal for our cooker because it works off 12 volts. So it's very easy to do the electrics. There's no danger of electric shock here. It's waterproof, so if any of the food were to spill on it, it's not an issue. It will stand temperatures up to 200 degrees centigrade. Easy to wire up, I said, so you just wire it up to the charge controller and it'll work straight away. It's low cost, around 10 or 15 pounds, and it's widely available throughout the world. And using one leisure battery, it gives us around 5.5 hours of cooking time. You can, of course, expand your system if you wanted to. So that first column is the one I talked about, which is using a 100-watt panel and one battery. So it's a concentration factor about 2.5. So you need to store energy for 13 hours to give you around 5.5 hours of cooking. And that's pretty much what the PV panel and the battery do, allow you to harness the solar power small bits at a time. So you might have half an hour of sunshine, you save it in the battery, bit of cloud. And then you might have another half an hour of sunshine, that's saved in the battery. And then by the time it's nighttime or the next day or the day after, you've got all the little bits of solar energy stored in the battery to allow you to cook, which a conventional solar cooker, be it a parabolic or a box cooker, doesn't allow you to do. If you wanted to cook every day, then you might have to put more panels in. So this almost parity in terms of time to charge and time to cook, if you can put 2 panels on. Or you can also increase the battery to give you much more cooking time. So if you just wanted to cook at the weekends, you could have 2 panels and 2 batteries, and it gives you 11 hours of cooking with the 2 batteries. So very much, everything here is very much do-it-yourself, made at home. All you need to do the cooking part is the heating element and an insulated box. So conventional slow cookers, these are slow cookers that work off the mains, use about 500 watts of power. Our solar-powered 12-volt cooker takes about 120 watts. So this is the first one we made. We just prototyped it with a cardboard box, used some building insulation, Kingspan, usually used in lofts and wall insulation. We lined it with tin foil, covered with aluminium foil, and we were able to cook with that rice, stews, bread, etc. Our Mark II one was slightly more sophisticated. We used wood, and we used rock wool insulation as used in lofts, but you could use sheep's wool as well. And that shows you a stock pot set inside. And then we have the metal lid and another lid with insulation to go on top. And our Mark III one, which is our current one, is built a bit like a conventional or a microwave oven, again made with wood, rock wool insulation all around and in the dough as well. And inside there's a metal box for cooking in. Some hints and tips that we picked up along the way in cooking with this. Obviously keep the heating pad here in contact with the pot, because that will maximize heat transfer to the cooking pot. And using a Dutch oven means that the whole pot heats up and you get nice even cooking and making baking easier as well. The heating pad, never try and use it without a load on it because it can overheat. So always try and put a load on it. Although it can stand up to 200 degrees centigrade, it's not wise to let it run away. So always switch it on with a pot on it. This stops it from overheating. So think of it like not using a microwave without actually something inside it. One of the issues with just connecting the heating pad to the battery is that it could discharge accidentally if you forget about it. So we added a timer, and we also added a thermometer just to keep an eye on temperature. These devices here, they're watt meters. They keep, they show you what power is passing through a device. So using that will allow you to keep an eye on your system. That's telling me that the heating pad is taking around 134 watts on there. And if you've got two, then you can monitor power going into the battery and power coming out of the battery. So you can see the performance of the system. So this on a sunny day. On this one is showing me that 105 watts is going into the battery. And on this one is showing me that 122 watts is coming out of the battery. So effectively, I'm only taking 17 watts out of the battery from a heating pad because I'm topping up the battery as soon as we're using it. It's worth mentioning at this stage that one of our prototypes was actually a hybrid cooker, which could solar cook from the sun as well as electric cook from the pad at the same time. And it's the one that Michael saw at the Green Gathering Festival that we had in Chepstow. But the issue with that, of course, is that you have to cook outside. So you have to keep carrying the cooker inside and outside. And two, the insulation of the glass isn't as good as what we've got on this product now. So for that reason, we replaced the whole thing with an insulated box and took the glass out so that we could use it in situ in a particular spot all the time. But this way, if the sun is shining, the battery tops up. So people might be interested in the cost of this system. Remember, all this was built in-house using material that was available apart from the bought-in items. So 100-watt solar panel, £100 these days, that's just over 100 euros. The lead acid battery is £120, again, around 130 euros. Charge controllers are very cost effective. The heating element is around £10, maximum 15 euros. You should be able to get one of those. The insulated box, these are the bits I had to buy, and this was made with material that I already had at home. This is for the timer control, etc., to make sure that the thing switched off after a set time. So in terms of total cost to build this, the board is £260. So under 300 euros to put a basic system together that will allow you to cook in the evenings, inside, and even if you haven't had any sun or very little sun in the day. So a bit about cooking power for this. So looking at a solar box cooker or a panel cooker, typically around 50 to 60 watts in terms of cooking power. And thanks to Dave Oxford to giving me some guidelines on measuring this, I was keen to measure the cooking power of our electric 12-volt electric cooker. And this is a method that Dave Oxford came up with. So heat a liter of water up. One you can do at home. And when the temperature difference between the water and the outside is more than 50 degrees C, monitor the temperature rise for 10 minutes. And if you multiply that by 7, it gives you approximate cooking power for the device that you're testing. So that's me doing that with a thermometer inside, that blue line there, and a thermometer outside. And I'll go through that to give, and I got a cooking power of 56 watts. Of course, it's possible to put 2 heating elements or more heating elements, but I was keen to keep the cooking times very similar to solar cooking with a box cooker or a panel cooker. And with 56 watts, it's very comparable to conventional panel cookers and solar cookers. What can you cook? So
just an information, 10 minutes left.
Okay, thank you. Thank you so much, Michael. Yeah. So there's rice you can cook in there, stews, curries, bread, cakes and scones, and biscuits. So the array of things that we've cooked in there. So use less water because the water doesn't evaporate away like you do when you're cooking on a fire. And the method is to heat the water up for half an hour to 45 minutes, then add the rice, and then at most, depending on the quantity of rice, another couple of hours, and you've got enough rice for 4 portions. So that's around 3 hours of cooking for rice. And that's bread that we made in the 12-volt cooker. That's the bread dough recipe. So that's the Dutch oven. We put a trivet on there to rise the bread off the base of the oven because that meant that the bottom didn't get burned. And that's the Dutch oven sitting inside our 12-volt cooker. So preheat the oven. Thanks to Jane for that. So that's again roughly 3 hours to make the bread. So that's the bean stew. I'm going to click through this fairly quickly, so around 2 to 3 hours. So just to get the best flavors, the oil and the onions and the garlic gets heated up first, the rest of the vegetables, and then in for 2 to 3 hours. Just obviously cut the pieces small and not too much liquid. You can buy 12-volt cookers off the market. These are designed for truckers, I believe, for them to heat up or cook meals on the move. So this one here is called a Road Pro, which we evaluated. It's molded plastic construction, metal on the inside. Takes around 70 to 100 watts from a battery. I measured the cooking power and it's comparable to the one we made. Because of the price, I think it's made in China, it's around £50, but I have to say it's very effective. It does make bread, cakes, as you can see from the next picture here. So that's pineapple upside down cake made in the Road Pro, and that's stewed fruit made in there as well. There's another 12-volt cooker from Australia called the Travel Buddy. It's around £200. And I have to say, that's very disappointing. The performance of that doesn't come anywhere near the £50 cooker that is made in China. So just, in the end, I think there's just 2 or 3 more slides. Benefits of cooking with stored solar energy. And remember, these are standalone systems, off-grid, completely off-grid standalone systems, portable as well. So the technology is here and now. I know there's a lot of research going on in terms of storing solar energy in materials, in phase change materials that can be used later for cooking. There are trials going on as well, and we heard a lot about this in Faro last year, but they're not quite here now. They're expensive, and they don't store the energy for more than 24 hours, as far as I understand it. So there are some disadvantages with those. Whereas with this technology, it is here and now. Parts are widely available. So in places like Bangladesh, there's like 3 million homes that have got solar panels and batteries for lighting, charging phones, etc. So the solar power revolution underway, and this sort of cooking could piggyback on that. The technology is very easily understood because, as I said, it's being rolled out in developing countries very, very fast and easily maintained. And the biggest advantage it gives you is you can cook indoors on cloudy days and in the evenings. Modest cost, and can be made in the cooker itself can be made pretty much anywhere in the world. There's no need to make it in China for low cost. It can actually be made anywhere in the world. I'm talking about the cooker, not the PV panels. It also doubles up as a hay box. So it is an integrated cooker, because once you finish cooking, or even halfway through cooking, you can turn the power off and it carries on as a retained heat cooker. We call it a hay box in the UK, but retained heat cooker or fireless cooker, thermal cooker in the US. So it can carry on that. That's an experiment where we finish the cooking, you put a blanket for extra insulation and let it cook under its own heat. And last, this might be the one that we saw Michael at, or might have been the next one. That's us at the Green Gathering with the 100-watt panel, the cooker, and the batteries just underneath this table. And that's me finished. Thank you very much. Thank you.